Sergey actually works as a professor in Gitna University, and he's a leading researcher of this institute for problem in mechanics and thermal gas dynamics and in a combustion laboratory. I'm correct? Okay. His area of expertise is the combustions of heterogeneous metal, combustion of solid propellant, structure, physical, mechanical, and thermal property of composite material, and turbulent combustion of premixed gases. Okay.
Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. My talk is about thermal hydraulic model of the building and fire. The problem is to predict dynamics of the fire propagation in building with a big number of premises, and to define a more probable waves of the fire and smoke spread in the building, and the risk assessment in fire, and to develop a tool for elaborating behavior of strategy in fire, and develop a tool for elaborating of the firefighting enterprises. The goal of our work is to develop a tool for engineers and for building designers to create a model which allows calculating a different situation in the building at fire. There are a few methods for simulation of the fire in premises, in buildings, in rooms. For example, I don't speak about very complex methods, for example, large area simulation method and EDF method. And there are field and zone models, but these models have a big limitation because he has a very complex for calculation of big amount of the premises, and it cannot calculate a big variation in condition of materials and condition in environment for different situation of the fire spreading in the building. The next one is the network models. These are stochastic models in which building is considered as a Markov chain, and introduce transition probabilities by these very formal models, and there are no a priori information about transition probabilities, and it is necessary a lot of statistical and experimental data for calculation of such model, and these models don't use results of combustion theory. Because of this model are more formal and cannot be used without a big volume of experimental data. Our goal is to develop a model of fire smoke spread in building which takes into account the peculiarities of the building's design, takes into account the properties of materials applied in the building, allows assessing an influence of variation in building design, random conditions. For example, you can open, close windows, door, you can switch on or switch off air conditioner. For example, the environmental condition can be changed. For example, the direction of the wind can be changed, and it is necessary to calculate different scenarios to calculate spreading of the fire in the building, and to find more probable waves for spreading of the fire. But we consider not only fire, but spread of the smoke and combustion pollutants in fire. Because of this, we consider two kinds of model. The first one is a hydraulic model of the building. This model considers a building. For example, this picture shows the realistic building. This is one of the floor of our faculty, And we consider a building without fire as a graph. The vertices of the graph are the premises. The branches of the graph are a channel for conduction of the airflow in the building, and black circles are exit to environment. And in the scheme of the building, the bars are the air conditions, and we consider the only doors and windows as a in this scheme. We consider a door and windows as a channel for air flow in the building and outside of the building. And each channel in the scheme are characterized by some parameters, and these parameters is a usual hydraulic parameters of the system, and we can calculate flow of the air in the building without fire. This slide shows a model of air flow in the building. This flow are described by the by a few equations. The external equation connected with aerodynamical pressure of the air around the building, hydrostatic pressure, and pressure in far from the building. And hydraulic pressure drop between premises or vertices in the graph is described by the expression which takes into account the hydraulic drop of the pressure and pressure between buildings. And one of the premises in the graph are the exit and entrance of the air conditioner, and drop pressure of the air conditioner are considered as a constant parameter of the air conditioner, and can be switch on or switch off depending on the situation in which we calculate the process. To calculate the pressures in different premises or in different vertices of the graph, we consider a flow condition of flow balance, and this condition allows calculation by pressure in each premises and flow rate of the air between premises without fire. But if we have a fire, this flows carries out smoke or pollutants, and these processes are described by the system of equations, mass balance. And in this equation, the first one describes the rate of production of smoke or pollutants, and the second term describes the mass rate between premises. And to calculate smoke spreading in the channel, we use a diffusion equation, in which the equation VIK is a velocity in the channel which connects these premises, and we obtain the solution for mass flow rate between premises in the simple case. And these premises, this equation takes into account some delay of the spreading of the pollutants in long channels. The second step is calculation. Of course, one premises have sources. For example, in some premises are fire